Welcome back to this Let's Talk Data podcast, brought to you by Proact and NetApp. In our last episode, we delved into the fundamentals of Kubernetes and explored its role in modern IT infrastructure. If you missed it, please be sure to check it out. Today, we're delving into Kubernetes security. Joining us once again is our esteemed colleague Jonas Larson, a specialist in Kubernetes and containerisation. In this episode, we'll unravel Kubernetes security and explore the unique challenges posed by containerised environments and review strategies for mitigating these risks. And of course, we'll ask the question, are containers more or less secure than operating system-based application deployments? So whether you're a seasoned DevOps professional or new to the world of containerisation, buckle up as we embark on our journey into Kubernetes security. Let's get started.
There's a bunch of different things you can choose between, which also in a security context makes it interesting, because when you build security into a containerized platform with Kubernetes as the orchestrator, how do you know which components you use, which of them provide you with the security you need?
But if you can prove that you have met your requirements programmatically, then suddenly you can swap out, product A for product B, and you can run your test again, and you say, okay, we're still good, then we can go ahead. We are moving more into software development methodology, I think, to do stuff.
I should start requesting clothes changes between the episodes.
Yay! Has he changed his jacket? He's changed his jacket, right? Okay,
yeah.
Fine. Okay, wow.
Yeah, that's
okay,
why,
nobody
that's
mentioned.
Why I said it.
Nobody said. Hello, everybody, and welcome again to this podcast. This podcast is essentially a follow-on episode from our last episode around Kubernetes. We have with us our esteemed colleague Jonas Larson, who is our Kubernetes and containerisation specialist, head of DevOps at Proact. We talked in our last podcast about Kubernetes and containerisation in general, and whether this is a valid method for developing and deploying applications, and where it fits in the scheme of things with regard to servers, virtualization, serverless, etc. So please go and review that one if you haven't seen it yet. In this episode, we're going to be talking about Kubernetes security, and so I suppose really, where do we start this? Jonas, any ideas? Is Kubernetes secure?
Yeah, so that's the question, right? And
surely yes has got to be the answer. I mean, I'm kind of hoping.
Is anything?
Oh, the cynic dives in from the corner.
Yeah.
So I think I like to answer all of this. Is my thing secure with just one remark, and that is, what is your requirements, right? Because if you work for NSA or the equivalent in our countries, secure means one thing. If you're an online retailer selling baby clothes, security means a totally different thing. So I think we should probably discuss does Kubernetes, and we know since the last episode that Kubernetes is just one thing. So does the Kubernetes ecosystem, or does the Kubernetes distribution have the capability of being secure? And to that, I would say yes. But there's a lot of moving parts here. So
yeah, and we talked about it briefly, so let's touch on it again with regard to this episode. So Kubernetes is essentially open source, and it's managed by a foundation. Go into that in a little bit more detail for us again, Jonas.
Yeah, exactly. So Kubernetes was developed as an in-house project at Google called Borg, and then it was gifted to the Linux Foundation, who created something called Cloud Native Compute Foundation, which is maintaining Kubernetes. And Kubernetes is contributed to by all of the big players in the industry, like Google, Microsoft, Apple, IBM, and thousands of others that I forgot to mention. And but Kubernetes in itself is basically just a very, very small part of this ecosystem. So in order to have it as a functional thing that we use, we compare it to Linux. So Linux is the kernel really, and then all of the other stuff that makes it usable for us as an operating system is all of the other things that we need. And Kubernetes is the same. So Kubernetes is just the orchestrator. Then we need networking and storage, and we need different capabilities that we add on. And that we normally call a Kubernetes distribution when I speak to my colleagues that know what that is. But when we speak to people that don't have that much knowledge, we just say Kubernetes. As when we speak with people about Linux, we say Linux, but then we mean the Linux distribution. And in this context, we mean the Kubernetes distribution when we talk about Kubernetes.
And Christian, you raised this last time. This is the challenge here is there are so many elements to this. Yes.
Yeah, there is. There's a bunch of different things you can choose between, which also in a security context makes it interesting because when you build security into a containerized platform with Kubernetes as the orchestrator, how do you know which components you use, which of them provide you with the security you need? I guess Jonas has been around this long enough, so he answers this the same way that I do with everything. It depends, right? It depends on your use case. It depends on your requirements, as you said. But the way I guess containerization work is you share the kernel with the Linux-based host, right? So you basically share Linux between all the containers. So how do you secure an image? How do you ensure that the images you use for your application or your microservice is actually patched and updated and secured? We know how to do that with physical servers. We know how to do that with VMs. How do you do that in a containerized environment managed by Kubernetes that has a bunch of things spinning up and down seemingly randomly at will? How do you know what your estate looks like?
And the interesting thing about this is that with Kubernetes, we are forced, if you come from a developer side, then we have the same question. So how do I know that my library that I'm using in my code is secure? And I have a lot of libraries that I'm using. And so all of these questions that you just asked, Christian, is valid, but from a code-based perspective. But when we put that code in an image and then deploy it to Kubernetes, then we took all of that complexity and we put it in something that we then deploy into Kubernetes with all of its complexity as well. So, but I think the problem isn't new. The questions should be exactly the same. The solutions are new because the target is new. But in all honesty, this is exactly the same problem that we had before. So it doesn't really change much just because we use Kubernetes as the end target for our code. If we speak about code. So
right. So you're still basically susceptible to kind of these supply chain things that we're looking at in the industry as a whole, right? So if you have a library that has been compromised or has some vulnerabilities in it, and you compile it into your image and use it in your development, you're at the behest of whoever maintains that library.
Yeah. So
right?
Yes, most definitely. So supply chain is a real danger, real thing. We know that from forever, and just recently we had a good example of that again. So and obviously that is probably one of the most difficult things to know, because you can do everything right, and still it's not right in the end. It becomes wrong in the end. But also there's a difference between having software with possible exploits in your code base and also the ability to exploit them, because you may have something that you have to have, you have to do a lot of hoops and stuff before you can actually exploit it, and you're not exposing that. So there's a lot of levels in this that you have to take into consideration when you speak about security. And I think for me, this is my pet peeve. How do we know, or how do you know? That is my question that I ask myself and my customers. Because if you can answer that, how do you know that you are secure? Then suddenly you're free. you're free to implement whatever tool you want. We have lots of tools that you can choose from. So, but if you can prove programmatically that you have met your requirements, I'm not going to say that you are secure because that doesn't really mean anything. But if you can prove that you have met your requirements programmatically, in best case, then suddenly you can swap out, product A for product B, and you can run your test again, and you say, okay, we're still good. Then we can go ahead. So we are moving more into software development methodology, I think, to do stuff, which I think is a good thing. It's much more, as code driven by real tests instead of, we can't really have someone saying it's secure. That doesn't really mean much, I think.
And I think to a certain extent we're dependent upon, there are external bodies who are defining whether something is vulnerable or not. Sometimes it comes from the developer, where they will announce the fact that they realize that this particular library is compromised in some way, shape or form. But also there are other bodies that are going in and saying, yes, we've seen this in the wild, or there's we know that there's been a 0 day on this, and therefore we're fixing it. So I think we are always dependent upon other people sort of making sure that any vulnerabilities are announced, and those vulnerabilities we're then aware of and we can resolve. But that isn't, you're right, that's no different to any other environment. We do that with Windows, we do that with Linux, we do it with our iPhones these days or our Android devices. So it's something that is the norm. I suppose in this situation, is Kubernetes, is it any more vulnerable to this sort of thing because we're developing ourselves, or isn't it?
I think from a general threat modeling perspective, the code that you developed is probably the least secure. Well, not our customers, of course. They develop perfect,
fantastic code, amazing.
But other developers,
the best developers, yes, absolutely.
Other developers, but obviously that's not. It's a broad sort of, right? So we don't know that for sure, but it's a good idea to think in those terms. Another thing that has happened, we spoke the last episode about the Kubernetes being a single target. So it's also a single target for tooling, which makes it easy for companies to provide tooling to do stuff like image scanning and register scanning and so on and so forth. So the tooling is very, very complete, or at least getting to be very complete in the Kubernetes ecosystem. So there's no shortage of possibilities, and it's all driven by doing stuff programmatically and not doing stuff manually. So, for example, how do we know that our operating system is secure? Well, we have something called Center of Internet Security, which is an organization that tries to put together like best practices for different areas in our industry. So for operating systems, switches, Kubernetes, and so on and so forth. And then we have tools that we can use those. They are called benchmarks. So we can use those benchmarks and evaluate our own Kubernetes installation against those benchmarks. We get a result and we say, these are the things that we hit. These are the vulnerability that you have. And then you have to choose. And then we get back to the requirements and which level of security do we need and so on and so forth. But there's a lot of tooling available that makes it a lot easier. And I think a lot better than previously. Because we have all been there with the Excel spreadsheet, looking at point 37. Is the server doing this, that, or the other? Yes, no, maybe. And how often do you do that? Maybe once, maybe twice.
I'm pretty sure I still have that Excel spreadsheet somewhere, to be honest.
Probably, yes.
You mentioned something there, Jonas. You mentioned a registry and your images, right?
Yeah.
Those are things we haven't really talked about, but my understanding of that is that you have a registry where you have your kind of validated images in that you provide your developers with through Kubernetes, I guess. But so can you from a security perspective, can you scan the registry and see if there's, okay, we have all of these different versions of containers with different, well, not operating systems, but different configurations of libraries and tools and whatever. is there a way to actually scan those and eliminate and get rid of the images that might be vulnerable and replace the image with a new one? And then what do? Deploy again?
Yeah, exactly.
Is that how this works?
Yeah, so let's build an application with Kubernetes. So how do you actually do that? So you have to write code, probably at some point. So
or at least some YAML.
Yeah, exactly. You write your super duper application. Let's say it's a Go application, just for the sake of it. And then you need to have a carrier for that application. It has to execute somewhere. So then you use something we call a base image. And that base image you download from a registry or a hub, like Docker Hub, for example, speaking about Docker, or other hubs out there. And then on top of that image, you download an image, which is like a bare bones basic stuff, only the stuff
that contains
you
like the runtime for the programming language you're using, that sort of stuff, is it?
Yes, exactly.
Cool.
So in Go, for example, because it doesn't use a runtime, we can say Python instead, because then it becomes what you said. So then we need a Python image that has the Python runtime so that our Python code can execute in that. So that we take that one, we build a new image with the base image and our code in it, and this becomes our image. So this is our super application, and this is the one that we want to deploy to Kubernetes. We can't push things into Kubernetes. So what we do, we push this new image to a image repository. We could use Docker Hub, which is a repository. We could use Microsoft's Azure registry for this, or we could use something like Harbor or our own registries for this. It doesn't really matter. Same idea. So we push this new image, our super duper application, and then from Kubernetes we can only do pull. So we can only pull images from Kubernetes into Kubernetes from a registry. So these registries, especially if we're using like Docker Hub or Microsoft, whatever it's called, something registry, we can scan the images, like you said, Christian, for vulnerabilities, known vulnerabilities, and we can, for example, say that we can't use stuff that hasn't been scanned without, or if we're hitting, let's say, critical level of vulnerabilities. So that's from the registry perspective. We should also do code scanning when we're doing our versioning control. So in Git or whatever we're using, obviously we should scan the code. But this is more for developers to take care of this, of course.
Yeah.
But
so this is one with the programming itself. We can scan our programming code and define whether we're building in vulnerabilities or we're utilizing libraries that are known to be.
Yeah, exactly. So,
vulnerable.
But this is common knowledge and good sense. You should scan your code, but you still use that code to build an image with the base image and your code on top of that. You should still scan that anyways, just to make sure. But this has all happened outside of Kubernetes. What we could do is we could have something in Kubernetes that before we execute it in Kubernetes, so before we allow it to run. Let's say we run our own scanner in there and say that if we have a critical vulnerability, we're not going to allow this to run. So that's quite an interesting approach to this, because then we, again, become more free. So then we don't have to be that afraid of using, let's say, Docker Hub, if you don't want to use Docker Hub because it's on the internet, whatever that means. Because there's a convenience thing and there's a how do we know stuff is secure thing. If we know that stuff are secure because it's within our data center, I'm not sure that that's a great measurement of stuff being secure.
That's not true anymore. It used to be. It used to be not true, but it used to be something that we thought was true.
I mean, if you have a separate network that is totally physically separated and there is no access to that network from no physical access, then sure, then you're on the inside for real. But
and it's probably useless for everyone because they can't access it. So
wow, how
doesn't
can we
make any sense, right?
Mm-hmm.
But if you're in a Saab Gripen flying, you probably don't want that thing connected to the internet.
No. There are. I've worked in a bunch of those environments as well, where there is an actual air gap, physical air gap to those environments, and there is no way data can leak in and out because there is no way in or out.
But I think the real challenge and the real benefit here is if you can live with all of the great services that we have that we can use these days, if you can live with those and still be secure, then you have a massive upside and a massive competitive edge towards others.
So,
sorry, go Christian.
If I understand this correctly, you can basically go to Docker Hub or any of the publicly available hubs and download a base container image and add your stuff to it, and then you check it into a private repository because you might not want to put your own proprietary source code into a public hub, but you do it by combining the publicly available image with your code into a private registry, and then you deploy from the private registry instead. So you get both the kind of convenience of getting something that someone else built. You don't have to spend time on building the runtime part of it. You just create your own code, and then you combine that into whatever you deploy, right? So that gives you kind of the best of both worlds. It gives you the open source approach to making things available. You can at the same time develop your applications as closed source inside of your own data center and deploy them.
Yeah, we should probably touch a little bit on the open source thingy. So just because you use open source projects doesn't mean that your source code must be made available to everybody. That's not how it works. So, but if you, and this is very simplified. We can do, a couple of hours of open source.
Two whole podcasts just on open source.
Anyhow, if you take an open source project with a particular license and you change it, and then you put it out in the wild and sell it as something else, then you have to provide the source code that you have to that project. But that. To most people, that's not a real world problem because we just use an image, we do our stuff internally. Even if you sell something as a service, that's still not the problem. It's only when you try to push this as a separate, product that you run into that. And even though maybe that's not a bad thing because we're all benefiting hugely from open source, so why not contribute to open source a little bit? If you find a bug, why not? I mean, So how can we contribute? I'm not the programmer, let's say. How can I contribute? Well, you can report stuff that you see. That's one way of contributing. You can read documentation, and if you find something in the documentation that is wrong, it could be something as a typo or whatever, you can just let them know. And you can always contribute.
I have my kind of claim to fame there, which is kind of fun. I recently did something similar to that because there is a Linux distribution based on delivering Kubernetes that's called Talos. Talos, I don't know how you pronounce it, but they had an installation script for how you get a couple of Kubernetes nodes up and running on VMware vSphere. So this is how you do it. Was a script, and there were some minor things there that made it difficult for me to deploy it in my environment because it didn't connect to the right virtual switches. So I kind of figured out how that script worked and replaced it with some variables and did some changes to it and submitted it back to Talos as a pull request, and they kind of immediately just put it into production. So I have my name on some Kubernetes stuff in Talos based on how you install it on vSphere.
We don't need Jonas now. We'll just have you as the Kubernetes expert, shall we? That's the way forward.
Well, what I did.
Thanks, Jonas. Thanks for your time. Much appreciated.
I did some simple bash scripting. I didn't do Kubernetes. But yeah, it's a way of contributing back, right? They give me this software for free. I can play with it in my lab. I found something that I knew how to fix, and I didn't just do it on my own. Why not give it back to them? It might help someone else.
Yeah, and if you are a developer, and also to the companies out there, I mean, if you're benefiting hugely from open source, allow your developers to spend a little time maybe to give back. It doesn't take a lot. There's a lot of people using open source. It doesn't take a lot per individual to really keep this train going, and to really, we have advanced greatly, the past 20 years with open source, and we can keep going. So that's just a shout out to all of the people helping with the open source community.
And you can see it as well. I mean, you look at the level. I mean, containerisation has been around since 2015, but the level of progression of essentially the problem solving, because there were issues with it initially. There were issues with Docker initially with regard to the way that it did orchestration. So, but Kubernetes came along to solve those problems, and then other things have then improved Kubernetes throughout that period of time. So I think, yeah, it's a constant evolution because of the fact that people can see issues and the ways to fix them, just like Christian did. So I think it's really important that they're pushing it that way forward, but also they're securing it as part of that process as well, because there are people out there, they need it to be secure, therefore they take their time to secure it, therefore we can all benefit from that. So, but I think the other thing here that we're maybe slightly missing out on is this: the quantity. Security is really about how many holes there are to fill, if that makes sense. And I think if you look at something like most open source systems, Linux is a good example. But if you look at, let's say, Windows and the amount of holes there are to fill in a Windows deployment, and then you look at a Linux deployment, I would wager there are a shed load less holes to fill in a Linux deployment. But then you look at a Kubernetes-based deployment, it's far less again. So I think just inherently, it's got to be far more secure than the alternatives, simply because of the fact that there's just a massively reduced attack surface.
Yes, I think you're onto something there, and also because of the container runtimes like containerd, cryo, and so on, they are very modern and written recently. So, and I'm not saying that that's a guarantee to keep things secure, but they didn't have to take a whole lot of legacy into consideration when they built this thing. So if you want to change something in Windows, for example, and especially the way that Windows has been structured, it's not easy to just throw away stuff and say, okay, we're not going to do this anymore. So they have a huge legacy code base that they have to take into consideration when they're changing stuff. So it's more difficult. We spoke about microservices last time, kind of the same problem. And also the container engines, container runtimes, they are a microservice in themselves. They just do one thing. And because of that, smaller code base means less stuff to, as a programmer to keep in your head and to wrap your head around, more eyes on that. And it's a lot. I'm not going to say that it's always going to be more secure, but at least it has the potential of being reviewed more often. It's easier to review it. If someone gives you, the Bible and say, could you please, check this for typos? Or if they give you one sentence, I mean, the one sentence is going to be checked quite quickly and be correct. The Bible, not so much, I think.
Not so much, but I think, I suppose the other challenge that we've seen, we talked about briefly, is the fact that the open sourceness, and this is not necessarily my view, but I've heard it said, if everybody can see your code, which is what open source is, does that mean it's easier for them to find vulnerabilities in it? Yes. Nobody can see the source code for Windows. Nobody can see the source code for Apple, but nobody can see the source code for an iPhone. But everybody can see the source code for a Kubernetes environment, and indeed for the containers that they utilize within it. So does that make it more vulnerable?
Well, I said yes to your first question.
Yeah, exactly. Yeah, but
I'm not going to say yes to your second question. Yeah, exactly. So the first question was, does that make it easier to find vulnerabilities in that code? And the answer is yes. But that's also the benefit part of it as well. Because if everybody can read your source code and it's still secure, that says something about security, right? So if the only reason you're secure is that nobody can read your source code, then I think you're in a puddle, and it's getting deeper. So
yeah, security by obscurity is it doesn't work anymore, right? People are going to try things until they break something. Things being open sourced, it might be easier to figure out what to try, but it will also most likely be easier to fix.
Yeah,
right?
because the open source community checked this first, didn't they? They didn't just release something that they thought might be okay and expect everyone to use it. They checked it.
Then you also don't have to wait 2 months for a patch for someone because it hasn't been disclosed. Things get disclosed pretty quickly in open source environments, and therefore also fixed pretty quickly.
Yeah, and it's not like I mean, when you fly to the States, for example, and you have the tick box, are you a terrorist? Well, if you are, you probably don't tick that, right? And it's not like if you're a hacker and you want to attack Windows, which is obviously a big attack surface, it's not like they read the end user agreement and say, oh, I couldn't read the source code, then I probably won't. No, of course not. They will just decompile the crap out of it, have access to the source code anyway, and then start digging around. So this does not stop an attacker from reading the code. It just gives you the perception of security because you as a user doesn't do that and won't do that, and then they can market it as more secure. But I would argue that it's not inherently more secure anyway.
No. If you look at you mentioned it, Jonas. We had a recent kind of supply chain thing on Linux, specifically Debian Debian and Red Hat build systems, right? So the XZ utils, which is basically a compression library, had an SSH backdoor built into it by someone who had access to submitting and committing source code for that library, right? So it's a really, really well done thing. Odds are that this wasn't done by some independent code guy. This has all the hallmarks of someone sponsored by, let's be honest, a nation state. The thing they did was in the build process for newer Debian Linux distributions, they run a test suite and test stuff. During that test, it injected an SSH key into the build system of the entire distribution, making it possible for someone to log on, if they had the correct private key, without a username and password, to any Debian version affected by this.
Whoa.
Available anywhere. Right?
And this was placed into the source.
Yes.
Yeah.
Whoa.
Through a third-party community-maintained library.
Just to be fair, it never made it into Debian stable. It was caught before.
Didn't, because it was caught before.
Yeah.
That was my point. Some guy from Microsoft actually noticed that his SSH connections on the nightly builds that weren't really publicized yet took longer time than before by 500 milliseconds or something. He thought that was kind of weird, so he started debugging that. And figured out what was going on, and then it went from there. The thing is, and that's where I was going with this, is if someone inside of a closed source software or operating system provider had been compromised and did the same thing internally, that vulnerability might never have actually, or that remote code execution implant might never actually have been discovered. Because if you, let's say it was Windows, right? So you get a new update for Windows. The code was there. No one had vetted it. It was there. It was obfuscated to the point where people didn't actually recognize that it was going on. So if you had a someone inside of Microsoft doing the same thing with a Microsoft code, that would have made it into the wild, most likely.
And it did with, there's another provider with,
Yeah.
and I won't necessarily recommend them because I don't want to badmouth another company, but essentially a large, essentially monitoring tool that was installed at many people's sites. And essentially the update that they rolled out to everybody essentially exposed the monitoring tool and exposed that customer's site to an attacker. And they rolled it out, and it was out for ages. It was out for months before they actually realized what was going on. So it does happen in both of us.
This kind of highlights the other part of the open source thing, right? So someone caught it, they figured it out, and they fixed it before it was released into the wild. While if this was closed source, it might have been available for years before someone actually noticed this was going on.
And to be fair, open source is no guarantee that it will be caught, but open source has an incentive built in for other people to watch, the code, to inspect, to try it out, and to do stuff with it. And closed source has a legal obligation not to. So there's a very, very different approach to security in those two worlds, let's say. But there's a lot of stuff out there that isn't. I mean, as soon as we write software, we have bugs. And no one is going to argue otherwise. And to the best of my knowledge, at least, the best way we have is to expose everything that we write to as many people as possible, to catch these things as early as possible. And, I don't know of a better model. Closed source is not a better model, for sure. Than it's just one company. And even at this company, it doesn't matter which company, there's no difference in whether it's Microsoft or Apple or whomever. There's a team for this particular thing, and that team may be 6 people. So it might be 6 people that have put eyes on this, and not even 6 people because it were 2 people, basically. One that did the code and the peer reviewer that reviewed it. So it might be 2 people looking at this. So oftentimes we think of, like Microsoft, we think of thousands and thousands of people. Yes, they are, but this one thing may maybe have been written by one person and looked at by another person, and that may be it.
I actually recently saw some Microsoft guy on Twitter or X posted a screenshot of the format dialog box for formatting hard drives and USB devices and whatever in Windows, explaining that this was a mock-up he did 30 years ago, and it hasn't been changed since because no designer actually did anything with it. It just was committed as
went
is.
into production.
So the mock-up that the developer made is actually the user interface for the format disk command in Windows still, because no one's touched it since, right? Well, so that's an example of how many people actually look at this before it's.
And that's valid in open source as well. So we touched a little bit upon before. So what do you choose? There's a lot of stuff to choose from. So one way of choosing stuff is to, do what's popular, because then you have more eyes on it. So that's one thing. If you have something that and today when the code is available at GitHub, for example, you can see how many contributors are there. There's stars on that thing, so you can see, there's only one contributor and no stars on this thing. So I'm the first user of this in the wild, and so on. I'm not saying that should be your only way of judging this, but definitely one way of looking at it. And obviously, you can look at what other companies' distributions are doing in Kubernetes. So if everybody is using a particular product, there may be a reason for that. Not saying that you have to do that, of course, but...
but again, you're down to just going back to your first point, you're down to your requirements. The end of the day, you could, if you wanted an ingress server, then you could use Nginx as your ingress server. I think that's right. But the point is, there probably are about 30 other ingress servers that you could utilize if you wanted to, but that's probably the most popular. But there may be something it doesn't do that you need. So therefore,
exactly.
you
may have to use. Yeah, you may have to use a service mesh, for example, because you want to do something particular with the networking. You may want to do like blue-green deployments or whatever, and you want to use Istio service mesh, for example, and something like that. But again, it should be your requirements that dictate this. It shouldn't be whether or not it's a shiny thing.
We love a shiny thing. Let's be honest. We do love a shiny thing.
Yes, but also had a new kind of brainwave here on the security part of things. If you deploy your applications as containers managed by Kubernetes, everything is hidden behind pretty much the load balancer or whatever you put in front of it, right? So let's say that this SSH thing had made it into the wild. You deployed an application based on an image that had that exploit in it. The key was in it. It wouldn't really make a difference because
behind a firewall.
No one is actually SSHing into the container itself. So the vulnerability there would be obfuscated by the fact that you wouldn't be able to connect to it that way.
You wouldn't be allowing that port through.
No, but what's the point in SSHing into a specific container in a Kubernetes environment? If you have an issue, you fix that and you deploy it again with fixing the issue. So you don't do that on an individual basis. So it's basically back to what I've been talking about for years in the virtualization space is your VMs are not pets. They're cattle, right? So the analogy between pets you care for, you feed them, you kind of do the household things. Cattle, that's food production. There's a difference. And yeah, whatever, right? It's so you don't kind of babysit your containers or VMs anymore. You automate them and you rip them away if you need to and redeploy them if you need to.
Yeah. And even more so in the Kubernetes ecosystem, because a VM is fairly heavy. And in Kubernetes, you always want to deploy your deployment. It's called a deployment. So it's difficult to speak about deploying deployments, but
exactly.
That's the way it is.
Terminology sometimes struggling.
Yeah, and then you always have at least two, because you have a built-in load balancer in Kubernetes. So you have two, which means that one can explode. You still have the same functionality, or you can have 5 or 500, and that's the same thing. So that's a concept that you should always stick to. And also bring it back a little bit more to Kubernetes security. Kubernetes.io, which is the official place of the Kubernetes software, has guidelines for you to use, and there's something called Pod Security Admission Controller, which is basically ready-made security levels that you can use. And by using the recommended version, you remove like 95-ish% of all the attack surface that is even possible to do. So even if, to your point, Christian, even if it's in an image that you're using, it's not going to be possible to exploit it anyway. So
you can't access it. So
it's not.
How can you exploit it? So,
exactly. Yeah. And even in Kubernetes, you can do more. You can do a lot with security, but you can, for example, have read-only containers, so you can't change anything in the container that's running. And so there's. I think we began this talk about. I'm stating that you can achieve the security goals that you have set up in Kubernetes. I think more so than in most environments, and this is probably because it's new. And when we implement this at the customers, whenever we implement something new, then everything that we wanted to do with all of the old stuff that we couldn't do, then suddenly we want to do it with this new thing, which I think is great. We should obviously always do that. We should do it with the old stuff as well, of course. But
so that makes Kubernetes the shiny thing now.
Yeah, I think so, actually.
I think to be honest, Jonas has been holding on to that shiny thing since 2015. I think, to be honest, it's
I think it's been
still infatuated.
Enforces good behavior, which I think is great. So we should enforce this good behavior in other stuff as well. But if something got built, like let's say VMware, I'm not saying VMware is insecure, but if you implemented something like 15 years ago, and a lot of stuff has happened in the industry since then, and a lot of new threats has come along, and we should do more things, and we're probably not doing it, and we have the old spreadsheet that we're looking into every now and again, and so on. Kubernetes has driven things to be done programmatically, which I think is fantastic, and coupled with as code and like Ansible or something like that, it gives for a much better, much faster way of working, much more secure in the sense that we know that we have defined what we want, and we can evaluate whether or not we have it, which is what we want.
Yeah, and it also opens up micro network segmentation between the containers. They can't talk to each other, and we don't have everything on a flat network anymore in Kubernetes either, right? So you have different namespaces, different IP segments.
We don't talk about that, do we?
And you isolate them from each other by default.
Yeah, we should speak about that a little bit, because in the old days...
Yeah, the old days. But what are you on about? Most of us are still doing it.
Like yesterday.
Yeah, the old days are yesterday. The old days about 20 minutes ago. Yeah.
No, but I was pre the eclipse.
we did stuff a certain way, and then it kind of cemented, like, this is how we do things, and we kind of forgot why we did them. And we experience this a lot when we speak to customers about security, because then we say, what are your requirements? And they say network segmentation. But that's probably not the requirement, right? That's
that's the defense mechanism they've used.
Yeah, implementation for the requirement. But everybody forgot the requirement. So this is something that we have to talk about with customers, that, okay, but this is probably not what we want. Probably we're saying that we need to separate things. Separation of duties, and probably we don't want, if application A shouldn't be able to speak to application B, then it shouldn't. But that doesn't necessarily mean network segmentation. It can mean something else. And that's something to have in mind, that in Kubernetes, we can meet all of the requirements, but we can't do it like we did before.
Yeah, exactly. So you might say that you have an application that's split into multiple individual components. Well, the interface element of that is maybe presenting for the customer should be able to speak to the engine that's running, but shouldn't be able to speak to the underlying database, so that nobody can talk directly from the interface to the database. So if they manage to break that one element, which is the primary element they can see, it doesn't allow them access to the underlying database. So you can design that quite easily into a containerized environment, but it's very difficult to design that into a normal application environment unless you separate all those things out onto individual servers. But again, each of those servers then has a massive attack surface.
Yeah, and you can also push down the requirements, which I think you should. So a developer should know all of the requirements for the application, including all of the security requirements, and they should be responsible for all of them as well, I think. I think it's a hole in the head to have a security department that is somehow responsible for the security part of an application. How does that even work?
Security isn't a different function.
No, exactly.
It's a part of the infrastructure.
Yeah.
But that's also something we must not forget in all of this. And that's all the things that we already do to secure our storage, a persistent storage and infrastructure, we also need to do, even if we're running Kubernetes. Because if someone can access your storage admin and delete your data or encrypt your data stores or whatever, that's going to affect Kubernetes that has its data written there as well. So Kubernetes and containerization doesn't eliminate having to actually properly secure your infrastructure as well.
Yeah. So we have the building blocks of Kubernetes, and the building blocks of Kubernetes are really, really simple. Basically, servers, physical servers. I'm saying what we have to do, not what we can do. So physical servers and storage. Obviously, we need network and power and stuff like that. But so there's no need for a VM environment, for example. We don't need to use VMware or KVM or Hyper-V or whatever. Kubernetes is designed to be resilient by distribution. So we shouldn't we don't have to use like the most expensive server with triple redundancy and stuff like that. We can use simpler servers with less redundancy and trust that we have multiple of them and let them fail and then just add new ones. We don't need to have the same capabilities in each server, for example, so we can mix and match. Very common, for example, if you have GPUs for that type of workload. So maybe you don't have enough money to have GPUs in all of your servers.
They're very expensive.
Or basic money or the actual physical GPU.
Yeah, exactly. Getting them these days is a challenge.
I ordered 50 of these. I got 2. How do I use them?
Yeah, exactly. Quick.
So, yeah.
Mirrored pair.
And obviously in Kubernetes, you don't want to... And then we use Kubernetes scheduling, orchestration to only allow certain types of workload on the GPUs, because we don't want our online retailing baby clothes using our GPUs. We want the calculations and that stuff using the GPUs.
I'm so interested you went with baby clothes on this situation. It's lovely. It's not what I thought.
Something else.
Yeah, exactly. Not what I thought. But I've got to say, it's been a fascinating conversation. Went all over the place. Was not necessarily expecting it to be. But yeah, no, really enjoyed that. Thank you very much. Cheers, Jonas. Thank you very much for doing that. Can we finish off with, I suppose, from the point of view of, for security-wise, I think the key element here is, if you look at it from an attack service perspective, this is a very secure system. I think there's a certain amount of, best practice that needs to be done to make sure that everything is looked after. And obviously, the key element is then leading on to the developers. But this is a secure environment, isn't it, in general?
Yes, I would say at the base level, it is secure. Your requirements dictate the security level that you need. You can't say that we want a secure system.
Yep. Christian, your thoughts?
I agree. I like the way that you, with Kubernetes, you can reduce the attack surfaces of all your underlying services that you manage with it. And by doing that, you are inherently more secure than running monolithic VMs or apps with a wide open networking plane. That is way too common these days. But at the same time, just make sure that you actually secure the underlying infrastructure as well, because there's still a need for it. There's still a requirement for it. Containers and Kubernetes doesn't eliminate the need to have memory, network, CPU, and storage. You need to secure that as well.
Agreed. Great, guys. Thank you very much. Thanks, Jonas. Been great having you with us. Thank you very much indeed for your time. And thanks. I hope everybody enjoyed the podcast.